I'll say from the research outcomes point of view, this talk was kind of inspired by the generative assembly design outcome. Leah and I met most recently at IDETC, which is the biggest mechanical engineering conference in the US, on the academic side at least. And her work really resonated with what we are trying to achieve in GAD. So I'm excited that she's giving this talk, and yeah, Leah, I'll hand it over to you.
All right, thank you. Okay, let me try to share these slides here. I just got a new laptop, so I'm gonna see if this works. Okay, can everyone see this?
We can see the yeah, the PowerPoint slides. It's not full screen.
Yeah, we see the presentation notes.
The presentation, that's it.
Oh, I see. Let me just. Is that doing the same thing? Okay.
That did the same thing. Yeah, now we can see the whole desktop.
Oh,
but
that works.
I think that looks good. No?
Well, that's still the presentation notes.
We
maybe at the display setting at the top.
Sorry about that.
There's a couple ways to go.
Okay, great. All right, can I get started?
Yes, please.
Okay. Yes, nice to meet you, everyone. Good morning. My name is Leah, and I'm going to be talking a little bit about my research today. And it's my pleasure to be here today. I've met Danny at IDTC conference, as he talked about, and I'm very excited about what's going on at Autodesk. And also, I do see some opportunities for mutual interest. So I'm excited to share this and get your feedback and also just input on my research. So I've been mainly working on this topic of human-centered engineering design with AI, which is, I understand it's a very broad topic. So I will specifically be talking about what that exactly means for me. And I want to share about this image a little bit before I begin. So this is an image that I generated using a generative AI model. And I prompted it, a designer and an AI designing an engineering product together in a human-centered manner. And obviously there is an AI system, some embodied robotic system here, working with a human designer on some type of engineering product. But you can see that something that is missing from this image is really what does it mean to be collaborating in a human-centered manner? And I've done this multiple times on generative AI, and really this essence of human-centeredness isn't really represented very well. And this exactly is the question that I continue to ask myself as a researcher. And this is really the main motivation of my research. As AI enter into the design process, how do we keep the design process human-centered and designed for people? So to give you a little bit of a background, this is the product design and development process that maybe a lot of you are familiar with already, which goes all the way from the planning phase to the production phase. And there's obviously the concept development, detailed design, and different phases of the design process. And as AI is entering this design process, main research focus has been on these two phases of the design process, the concept development phase and the detailed design phase, concept development being, coming up with a lot of ideas and stretching designers' creativity beyond what they can currently do, but also detailed design phase, which is mainly, optimizing the designs and deciding on the detailed design parameters and making that process more efficient with AI tools. So these are the two phases that have been the main focus. And I'm going to talk a little bit about how I would like to take this a little bit beyond these two phases of the design process. But this is kind of a background on what AI research has been within engineering design. Here are some examples of what an AI can do in the design world. As you can see, there are a lot of cool architectural designs and gaming consoles and chairs and helmets. There are so many different applications to this, and AI has been showing a lot of potential in coming up with creative and cool ideas, but also in engineering design, really optimizing the designs like the lightweight helmet that you see at the bottom. So I just wanted to show you this, and it's very cool, very exciting applications of AI. However, something that I want to pose to you guys is that design is a very human activity. And this is something that I've personally, as a researcher, has been struggling with as AI is entering the design process. How do we preserve this humanness of the design activity? And I want to give you some explanation of why I think design is a very human activity. The first group of people that's within the design activity are obviously the designers. And the designers in this process really use their empathetic skills to relate to the users in the very early phases of the design process. And then they use their creativity skills. And then some designers really similar to art, use this as a way to express themselves as well. So really, this design activity isn't just coming up with the most efficient and most best working design, but a lot of times there are these human components in the design process very prevalently. And then the second group of people are the users. So obviously, these users and consumers are communicating their needs and preferences. And then this is where the designers take in and empathize with these needs and come up with new solutions for their problems. So these two groups of people are inevitably within the design process. And even as AI is entering the design process, these two people still remain. And as long as we are designing for people and designing for end users, design will remain a quite human activity. So with this in mind, something that I started thinking about is, do we really want to create AI tools for design? Or is it really, we have to create AI tools for designers? And to me, creating AI tools for designers is really the biggest goal of my research. So this is one of my main objectives as a researcher, building AI tools for designers. And I'm going to talk about a few different ways in which I have been doing this. I'm going to introduce you and kind of brush over some of the main projects that I've been working on. So the first being, I have worked on increasing visual feasibility of designs that are created by text-to-image models, and also increasing the ease of design input communication. So here, text-to-image models have been gaining a lot of interest in the design world as well, because of its benefits of using image data sets, which is, large data sets, and it has the potential to come up with designs that really pushes people's creative boundaries. However, the problem with these text-to-image tools is that a lot of times the images that they create are not visually feasible. And images that are visually feasible is very important in concept generation process, because for designers to really take that as a serious idea and go forward with those designs in the later stages of the design process, the designs need to be visually feasible, or else it is only working as an inspirational tool and no more than that. So we want to increase visual feasibility while retaining the creativity of text-to-image models, and also increase, a lot of times text-to-image models, the input is in the form of text. So we want to increase the ease of design intent communication, which is often not done in a text form in the traditional design process, but more through sketches and images and so forth. So something that I proposed in this work is this. I know it's a little bit pixelated, but hopefully you can read it. But we used remains the original text-to-image model, which is the bottom line of the process. And then we added the component at the top, which is basically along with the text prompt, we're also feeding in a CAD image that is semantically similar to the text prompt, and then generating images that are hopefully more visually feasible. And this is done by this CAD image kind of giving the text-to-image model information about what the characteristics of a feasible design, and then it'll take into consideration those aspects along with the text prompts. So let me talk a little bit about how this part works. So selecting CAD image prompt in this process works like this. So first, there is a text prompt at hand. And then after using the biked data set, which comes from a data set by Decode Lab at MIT, which consists of various CAD models of bikes, of about 5,000 bikes. And we're using the clip model to find the cosine similarity between the text and all the bike designs in the data set, and it finds the one that is semantically the closest to the text prompt, as which is chosen as the CAD image prompt that will go into the generation process. So some examples here. Here is a text prompt: an innovative bike with comfortable saddle, propellers as the wheels, and a cover made with glass in the future. So that's a prompt that a participant plugged in, and then it'll find a CAD image from the data set that is the most semantically close to the text prompt. And then we generated varying the level of CAD image prompting at the bottom, all the way from 0.35 to 1. And 0.35 is the lowest level because that was kind of on the platform that we're using, that was the lowest we could go. But as you can see, as we increase CAD image prompting, it becomes more visually feasible. However, it is compromising some of its novelty aspect of the design, which is pretty expected. And we wanted to formally evaluate the novelty and the visual feasibility of these images. So some of the results from this work show that visual feasibility indeed increases with CAD image prompting. And here I want to point out that SD represents stable diffusion. SD plus PM is stable diffusion on top of a feature that the platform had to increase the quality of the images, and then the rest are CAD image prompting on top of that. And as you can see, that visual feasibility is improved even with the lowest CAD image prompting strength. So you can see with the 0.35 weight, we still was able to increase the perceived feasibility. And the higher the CIP strength, the more visually feasible the designs were. So we can see this increasing trend here. And then what was interesting was at a very high CIP strength level, it seems to be confusing the generation and the visual feasibility drops a little bit. And we think that this is happening because the model is trying to balance the text prompt and the image prompt. So if it's too high of a prompting strength with the image, then now, it's getting confused which one to whether to put the text first or the image first, and it's confusing the generation. So that was visual feasibility. But in terms of novelty, as we could visually see, there is a kind of decrease in novelty as we increase CAD image prompting. So you see this general decreasing trend Some specific results, what we see is that with low CIP strength, novelty does not decrease compared to stable diffusion alone, meaning that with very low CIP strength, compared to stable diffusion alone condition, this difference wasn't very significant. So with very low CIP strength, we may be able to generate still quite novel solutions, but increase the visual feasibility, as I showed in the previous slide. And then with very high CIP strengths, we see this novelty plateauing. So maybe not increasing the CIP strength over 6.6 or 0.67 is desirable in terms of that appropriate level of novelty as well as visual feasibility. And here, some opportunities and impact of this research, we think, is first, the text-to-image models are currently, again, used as an inspirational tool only because of this lack of visual feasibility, but this can really increase the impact of it being used as a concept generation tool itself. And then also this really streamlines the design process. There is this disconnect if the images that are being created are not visually feasible. There is a disconnect between the concept development phase and the later stages of the design process. So this can really try to streamline that design process. And then also, one big benefit is that as we're using CAD images to guide the generation, we are able to create more synthetic design data sets in a controlled manner. So, for example, if we want to, right now, if we're creating design data sets with text-to-image models, really there's no great way to control that generation. But by using these CAD models, we may be able to control its visual feasibility as well as its novelty level. And then finally, communication of design intent through CAD. So right now we're using an existing CAD image data set and selecting the ones that are semantically closest. But instead of doing that, the designers can also tweak the CAD designs and express their design intent in that way and input that CAD image into the generation to communicate their design intent better. So this is one example of what we've been doing to create AI tools for designers. And I want to move on to the second work, which has been really addressing qualitative design goals. So in engineering design research, especially when it comes to AI research, a lot of the research has been focused on addressing quantitative design goals and how do we make that more efficient. However, in design process, as we all might imagine, there are a lot of different qualitative design goals at hand, such as aesthetics, ease of use, comfort, usefulness. And these are very important for the design process as well, not just the quantitative aspect, especially because it really determines the customer's preference and the adoption of these products. So AI tools eventually will need to somehow understand the qualitative design goals as well for better collaboration with the AI designers, with the human designers. So my previous research has mainly focused on the aesthetics aspect of meeting qualitative design goals with AI. And I have focused, so this is a proposed, I guess, plot of how aesthetics is described in literature. So in a very lower level, it talks about form of the design. So this is really syntactic attributes like it's angular and it's symmetric, wide, long. So it's a description of the visual aspects of the design. And then the larger group of that is composition of the design, and then finally interpretation, which is a little bit more of semantic attributes like, descriptions like beautiful, modern, sleek, cool. So in this work, what we're trying to do is how do we define aesthetics in a more objective manner, and can we communicate that to AI systems? So we focus more on the form aspect and try to define aesthetics into different groups. So in my previous research, I have, as a case study, selected one very engineering design versus a more aesthetic design component, so canopies and vases here. And then we just defined 16 different types of aesthetics using these 4 different attributes, syntactic attributes: width, length, curvature, and complexity. And then we made 16 different variations of these 4 attributes, coming up with 16 different types of aesthetic groups. So as you can see, these are some of the aesthetic groups that we defined from canopies and vases. And what we did in this research is we tried to look at whether aesthetic preference of a person carries across different products. And this way, maybe AI will be able to understand a person's aesthetic preference and then try to go off of that to create different products that meet their aesthetic preference. So we looked at vases of these different aesthetic groups and then mapped that with canopies of the same aesthetic group, and then tried to see if the user's aesthetic preference were carrying across different products, these 2 products. So some of the results here, syntactic preference-wise, we saw about 61.3% consistency, which is really vague. We don't really know what that means exactly. So we looked more into the consistency across attribute combinations. And we see that here, 31% were 2 contributes were consistent, 39% 3 attributes were consistent. So we see that a majority, about 70% of the users were consistent across their aesthetic preferences over 2 or 3 attributes. So this gives us some promising results that there is some type of aesthetic preference, transferring of aesthetic preference between different products, and the AI may be able to kind of interpret what each person's aesthetic preference is, and then try to create products that meet those aesthetic preferences. So with that, I want to also move on to talking about AI tools, not for just designers, but also for users as well. And as I was thinking about this, one of the biggest things that I've been thinking about is this issue that I first brought up, that AI has mainly been focused on the concept development phase and the detailed design phase of the design process. But really where the communication with users are happening are these 2 phases of the design process. First being the planning phase and the testing phase. And in this part, really, there hasn't been much work on how AI can help with this process and increase their empathy level and be able to create better user understanding of the designer. So that is exactly the focus of this work. We wanted to create, we started thinking about how can AI tools help in this user understanding process to reduce time that takes to understand the users, but also there's a lot of bias that happens as the designers are interpreting the user's needs. And also, how do we facilitate participatory design through AI tools as well? So the work that I've been doing here, it's quite preliminary work, but we started thinking about AI-assisted observation. So there would be some type of observational video of a human activity. In our case, we use the case study of IKEA assembly. So this is a video of them working on it. And we first started looking at more physical component of this video. So we looked at the pose of the person and defining what is a bad pose versus good pose. And then looking at the body part and object interactions. And then extracting this information led us to finding some ergonomic needs that this person is experiencing. And in this way, we are able to maybe provide the designers with information that they might be missing out on as they're observing this person perform an activity. And that is the goal of this work. We do want to expand this work to not just the ergonomic needs, but also other types of needs like emotional needs and so forth. But this is a work that we just started working on. And if anyone's interested, we have a paper coming out this coming IDTC conference on this work. So please let me know if you are interested and I can talk to you more about it. This is kind of how the current tool looks like. It is very rudimentary tool, but basically what it's doing is coming up with different problem points throughout the video that they observe, and then give them some type of explanation of what they think is happening and why they think there is physical discomfort that they see in the video. All right, so we now talked about building AI tools for designers. And then what I also thought about a lot is, okay, so now that we have these tools, we have to also understand how these tools are impacting the designers. So I do conduct a lot of cognitive science-based research as well in order to understand how these tools are impacting the design process and specifically the designers themselves. So I want to introduce some work that I've done through my PhD, the thesis, and it's on trust and reliance on AI recommenders. So a lot of AI systems in the design process at the moment is communicating its output in terms of recommendations. At the moment, there's really no overriding of decisions made by people. AIs are simply tools that give recommendations. So I wanted to generalize this research on AI recommenders and how people trust and rely on this and how it impacts the designer's confidence in the AI, but also in themselves. So this work, I've done it through two different tasks. First being the non-design task, which is a chess problem, and then second being a design task. And both of these tasks look very similar. They will receive AI suggestion on the best next move, and then they have to either accept that suggestion or reject it. I've looked at variations of AI performance. So the first condition, I started out with a high-performing AI that gives very good suggestions, and then eventually moved on. It switched to being a low-performing AI, and the other condition was basically the order is flipped. And then I also looked at designer competency. So how their confidence is impacted depending on how good of a designer they are or how well the designer is performing themselves. So with that, this is how the procedure of the human subject study went. So first, I've asked the participants to select an action without the AI suggestion first. So this is their own decision on what the best next design move is. And then they receive the AI suggestion at the top. And considering that AI suggestion, they were asked to make the final action. So this is, they could go with their own decision or they could accept or reject AI suggestion. And then after they've made that final action, they received feedback on that move that they just made. And then they reported their self-confidence and confidence in the AI. And this was repeated 30 times over the course of this experiment. So to show you some of the major results from this. So the top two plots are showing confidence in the AI results. And then the bottom two is showing self-confidence results in two different conditions here. The first major result is that we see this very high initial confidence in the AI, which is about 0.6, which compared to 0 in the scale of 0 to 1, we see that initially there is this peak of confidence, and especially throughout the process, we generally see lower confidence throughout. So initially they start with high confidence. And what we see here that you might already have expected is the confidence in the AI is very easily lost. So we see in this first condition, when it turned from high performing to low performing AI, there's a significant drop afterwards. But in the second condition, when it went from low performing to high performing AI, actually this difference in the plot, the change in the plot is not statistically significant, showing that it is very difficult to regain the confidence in the AI after they have lost your trust. We also see a very sad trend that in either condition, we see this decreasing self-confidence over time. And the designers, as they're working with the AI, whether the AI is high performing or low performing, they show this general decrease in their self-confidence. So this is a good caution when we're implementing AI recommenders into the design process. So after we looked at these task AI performance and designer competency, I also conducted some follow-up studies, first looking at number of AI suggestions and how that impacts the designers as well. So we added in a second AI suggestion and then saw whether that changed anything in the results. And here is the confidence when working with 2 AI recommenders. So the first plot showing confidence in AI 1, second AI 2, and then third self-confidence plot. And again, something that is again very sad trend is that we see this decreasing confidence in all 3 plots, both in the AI and the self-confidence. And as you can see, if we add second AI, which might be a little bit too much of a burden for them mentally, they're not keeping track of their performance as well as the first study where there was only one AI recommender. And then also what was interesting was that we thought that if there were 2 AI suggestions that are agreeing with each other, they would be more likely to accept that suggestion, but that was not the case with 2 AI recommenders. So here we see that really there might not be any benefit of adding a second AI recommender, especially if all the confidence levels are going down and it is not making them accept that AI suggestion further. Then I also looked at a factor of AI identity. So this is a study that I conducted looking at whether they know it is an AI suggestion or they think it is a human suggestion, but it is actually an AI suggestion, if there is a difference in their perception of the suggestions. And one major result that we saw here was especially when the person is a low-performing designer, it really impacts their perception of, or when the AI is low-performing, sorry. When the AI is a low-performing AI, it impacts their perception of that AI, depending on whether they know it's an AI or not. We see here that in terms of teammate competency, if it's a low-performing AI, they still perceive it to be much high-performing when they think that it's a human teammate. So it seems like they are more lenient on judging the competency of the suggestion, whoever the teammate, if it is a human versus an AI. And then in terms of teammate helpfulness as well, they are more lenient if they think that it is a human recommender and they think that they are more helpful than they actually is. And then finally, I want to talk about how I tried to model this formally. So I thought that it would be helpful to come up with a formal model of how human confidence changes over their collaboration with AI tools. And this can really inform how we give suggestions to people and what factors can we tweak to increase their confidence levels throughout the design process. And here, the human confidence model was done with 3 different factors. First being experience factor. So this is the experience that they're having in the previous trial, in the current trial. And then the accumulated confidence is their confidence level up to that trial. And then bias is the bias that they have for general AI system, not just this specific AI, but the thoughts that they have about the AI system generally. And this is what the model looks like. I'm not going to go in detail for this, but something to pay attention to is there is this experience factor, which is a linear combination of linear sum of four different experiences that they can have when they're interacting with AI. So you can see in this box, you can receive positive feedback on the AI suggestion or positive feedback on their own move, and flip that, negative feedback on the AI suggestion and negative feedback on their own move. So these are the four different types of experiences they can have in their interaction with the AI. And then there's this accumulated confidence term. And then as the time goes on, so the experience that's closest to the current trial is counted as greater than the ones that were further away because of time effect. And then there's this bias term. So what happened is we fit this model, we optimize the parameters of the model and fit that to the experimental data that we had from the previous studies that I run. And we see this generally pretty high fit of the model to the experiment data. So this shows that we may be able to kind of predict how a person's self-confidence or confidence in the AI will change over the course with their new experiences. We do see that with self-confidence, there's lower level of fitting here of 0.48. And we think that this is because self-confidence might not be as much dependent on the experience itself, but it is more internally motivated. So we're not capturing that aspect in this model quite yet. So this model is a little bit more accurate for the confidence in the AI and predicting that over the self-confidence level. And with that, I would like to go back to this previous slide that I posed, that design is a very human activity. And I do want to leave you guys off with some points of thought. And first being this idea of human designer, user-centered design, and what that actually means. And we really need to ponder upon this aspect. You know, we talk about human-centeredness, but really, what does that mean? And how can we actually apply that to research? Also, AI for designers, as I talked about, we think a lot about AI tools for design itself, but what does it mean to create AI tools for designers? Another thing is we talk a lot about in this research community about human in the loop process, but really what that implies is that human is the second priority. So we really want to focus on how can we keep humans as the main leader of this design process and place AI in the loop. And really, I want to kind of suggest this term to kind of shift the thinking on what it means to be human-centered. And then again, not just the quantitative goals in design, but we have all these qualitative design goals that we want to address to meet the needs of the users. And then finally, a lot of trust research that I have read have been talking about how do we increase the trust for AI? But really, the question is, do we really want to increase trust? Is that really the goal of research? Or do we want to have people appropriately trust these tools? And we want to think about how we can do that as well. And with that, I would like to conclude my my presentation. And thank you so much for listening. I know it's very early morning for all of you, or most of you. So thank you for your attention.
Amazing. Thank you so much. We can open up for questions. Please feel free to come off mute and ask our presenter any questions you've had or comments, thoughts.
Yeah, thanks, Leah. Maybe I can kick us off. Yeah, the qualitative design ideas really resonated with me, I think, because you know, we've been doing some work on our end, and that's always a hard thing to tackle. You know, it's much easier to optimize things that you can mathematically quantify. So I guess, yeah, just flagging a couple of opportunities. Definitely, I think the simulation around product assembly really resonated. I think we've been thinking about how that might happen, not with physical products, but maybe simulating CAD, potentially CAD assemblies. And so there might be, maybe that's definitely a thread that we should follow up on. As I think there is a mutual research interest there. And then, yeah, the opportunity around aesthetic qualitative evaluation, around form, also, like I said before, really resonated. I think that's something that, it's always, it seems to be like a user priority, but as we create design tools to automate design, it always ends up at the bottom of the list of things that you can optimize for, and it's certainly a hard challenge. So thanks for sharing some thoughts around that. I guess I had a couple of questions, but yeah, Nigel, I'll let you go first.
Thanks for that talk. I was wondering in the AI suggestion work on like with the trusses, how, so it seemed like in the results, the confidence was sort of like 50-50 for a lot of even for the high performing one. So does that mean that they would take only half of the time they would appreciate or take the suggestion from the AI? And then the other thing I'm wondering is how was there, like, how did they know whether they were improving the design by their choice? Like, would you give them like a score or something, or show them a simulation, or how do they know whether a choice was good or not?
Yeah, so the first question around 50 level confidence. So the way we measure that is more self-report. So it wasn't based on whether they accepted the AI or not. It's more on, they will report themselves how confident they are in the AI. Whether that would lead to 50% of accepting or not, we have to look more into. We don't have the results for that. But I do think that because this is more dynamic confidence rather than, at this point, their level of confidence is 50. And then for next 10 moves, are they gonna, 50% of the time accept the AI suggestion? That's more of a static confidence affecting the later decisions. So we wanted to look at more fluid and changes in confidence. So it's more of a self-report. And then the second question was on how do they know whether the decisions are good or not? So that is based on the AI itself. So it's calculating it in the back, but they're not getting the specific numbers as they're making the decision. They're just getting a feedback after final decision, whether it was good or not. So the calculations are being done in the back end, but they're not getting all the information about what the calculations are.
I see. So when you say at the end, you mean when they've completed their trust design?
Oh, no. When they completed the first, like every decision, they will get that feedback. And the goodness of that decision was calculated using our own AI model that's based on basically sequential decision-making design data set. So in this problem, there's sequences of decisions that were made, and with that data, there is that final design that it led to, which becomes the goodness metric. And there's the sequence of decisions and which sequence led to a better design. And it's trained on large data set of that.
Yeah, I was just thinking that, I mean, it'd be difficult to do it with every trust you add because you kind of have to do a few before you get something reasonable.
Definitely. Yeah, so it is a very difficult, I guess, task for the designers. And we do think that that has impacted the results a little bit too. because it is not a traditional way of designing a truss system, getting feedback after every design move.
I mean, this is interesting for us too, because we're thinking of like helping our users design assemblies. So connecting sequences of components together.
Mm-hmm.
And in a way, you can think of the truss like an assembly.
Mm-hmm.
But
Mm-hmm.
it's all similar elements, whereas what we're talking about is different elements as well. So yeah, it's definitely a challenging problem. Thanks.
I had a question for you, Leah, which was when it comes to like all the iterative design process and all the different iterations from like the early phase to mid phase, how do you see the AI tools evolving and kind of adapting to the traditional ways designers engage with critique and feedback?
That's a good question. Yeah, so I think, so one thought that I've been having in terms of this, AI tools for designers, and ultimately, I do think we need a more interactive AI tool that can receive feedback from people in really any form. And I think one way to go about that is there's a lot of work in terms of, Bayesian optimization and active learning, where it's selecting the best questions to ask ask a designer, and then it'll maximize the information that you gain from that answer. So I think in that way, AIs can almost create these questions that will give them a lot of information, and then give that to the human designer, and then it'll feed it back into the AI system and kind of retrain the system quickly. That's something that I have been thinking about, but I'm not exactly sure how that would work. But I do think, yes, there should be more of a feedback loop eventually in the system. Yeah.
Great, thank you. Evan, did you want to ask away?
Yeah, so I'm going to try and frame my question, but it might not be super clear. So when you started to look at the AI for formal attributes or attributes related to form, do you think that that helped the designers take more of a solution neutral approach, like overcome their historical design bias?
Mm. Hmm. I actually haven't thought about that very much. But what I did see was, so we did run a human subject experiment, well, not implementing the form, but really trying to see how designers currently balance the quantitative and the qualitative goals. And when they're using CAD systems, it's not a big component of their design in the beginning. It's more of an afterthought that they're trying to apply after they've optimized their designs. How do I tweak it here and there so it's a little bit prettier or something like that. And I think in terms of their bias from previous rounds, I mean, is the question, if we implement this form aspect to the AI, then we would see changes in their thinking, like their biases?
Yeah, I guess I'm just curious, like, commonly you're informed by what you've seen before, right? Like products that you worked on or things you experienced in your life. And it's just wondering if you saw any just change in the concepts developed because the the AI is developing a solution, absent of any individual's previous experience. Of course, it's going to be trained on things, but yeah, I mean, just something I was thinking about. So certainly not something I expected of it.
Yeah.
An
Yeah.
answer to like that's super developed.
Yeah. Yeah. So we haven't formally implemented the form things into the AI framework. So
Okay.
I guess no is the answer. But I do think that when we are thinking about implementing these, we can't just think about it's separate from people's previous experiences. So another research that I've actually been doing has been looking at, what does novelty even mean? So there's definitions of novelty in research, but really what we want is we want to wow the users, right? And when we're wowing the users, novelty is not enough because wowing means it's dependent on all the experiences that they had previously, and it needs to be different from that. So in the same way, I think aesthetics and all these qualitative measures are very similar, that it's dependent on their experiences, and we need to have a way to capture that into the model.
Yeah, one of these topics I've been interested in recently is this idea of starting from a solution neutral design approach. So rather saying like, I'm going to design a bicycle, saying you're starting your problem from, I need a human powered transportation solution, right? And then seeing how things develop from there. And I think there's an interesting opportunity for the consideration of form when you start to lay out those problems. So yeah, just a little bit of where my rambling questions are coming.
Yeah, no, that's a great point.
Yeah, to follow up on that, just a clarification. So the form research was were the results that you were presenting, those were for attribute alignment between humans or between human and AI?
Oh, this is between themselves. So for one individual,
Oh, okay.
yeah, if there is an attribute alignment between a vase and a canopy. And do their aesthetic preference basically carry across different products?
Okay, I see. Got you. So I guess it would be interesting to see, with if you were to throw the image at a VLM, would it also carry some attributes, or how
Yeah,
would those attributes align to people's
yeah, that's true.
preferences? Yeah.
Yeah. I think yeah, the main objective of this was trying to define it, see if it carries over,
Got
and
you.
thought that if, aesthetic component were to be embedded into an AI system, if it ends up being, it does carry over multiple products, the aesthetic preferences, we can give initial questions that AI asks to people, give different images of, let's say, vases. And then we can capture their aesthetic preference and then start generating some other products that match that aesthetic preference. So we were thinking about that and conducted this research.
Got you. Yeah, that makes sense. And another question around the self-confidence and how you saw it drop when AI suggestions were introduced. So you mentioned maybe it had to do with cognitive load. Can you talk a little bit more about that, why that might happen? Because, yeah, I thought it was an interesting finding.
Yeah. So I think the cognitive load part, let me try to go back to it. Yes, here. So here, this is where I talked about cognitive load. And I think because I've added an additional AI recommendation. So now they're trying to look at 2 different AI recommendations and work with them. And we asked them how confident they are in the AI 1 and AI 2 separately, right? And I think because they're looking at these recommendations and there's just two different AI suggestions, you know, it's harder for them to keep track of which AI did well and which AI didn't do well. And I think that aspect might confuse them and put a lot of load on them, which maybe leads them to making less good decisions. Therefore, their self-confidence decreases is one, you know, hypothesis we have why this might be happening.
But and you saw it also when there was just one AI recommender, I guess.
So it also decreased here, yes.
Yeah.
So why we think this is happening is a little bit separate from cognitive load. This part, we think that we see this trend of people tend to blame themselves for the AI's mistake and also for their own mistake, which is really interesting. So I think it's because they are the final decision maker. So if they accepted a bad AI suggestion, their self-confidence decreases, right? Even
Okay.
actually the AI did badly, but you also accepted that, right? So yeah.
Yeah, got you. Yeah, because in this experiment, you were giving the designer feedback after every step about, okay, so that's why I guess there's probably a one-to-one correlation between that score and the self-confidence in some way.
Yeah, so this was an attempt to basically look at how confidence changes. So we had to very specifically control the experiment, but we do think even if we gave them feedback, let's say after 5 decisions, every 5 decisions or something, we probably will see somewhat similar trends.
That makes sense. Great. Yeah, if there are no more questions, Nigel, did you have anything else?
I was just gonna comment, at least for, I mean, a thought that I have for this sort of confidence, at least in like image generation, I think often my experience is that initially I have quite high confidence with the results, but then the more I look at them, the more details that I notice that are wrong, and then my confidence goes down. So maybe it depends on the AI and exactly what they're producing. If it's something complex, then you may take time to realize how bad it is.
Yes, definitely. So we are actually currently doing an ongoing research, kind of comparing different types of tasks and how it impacts this differently. Because right now, yeah, we don't really have measures for how complex the task is or, yeah, what type of task is and so forth. So we do think there needs to be more research that needs to get done there. Yeah. Interesting.
Great. Well, I think we're at a good point to pause. Leah, I want to thank you so much for taking the time to give us that awesome presentation. Thank you for the introduction, Danny, and thank you everyone for joining. And I hope to stay in touch, Leah, and I will send along some wrap-up information your way as well.
Great. Thank you. Thanks for having me.
Thank you,
Thanks for
everyone.
the presentation.
Thanks. Bye-bye.